Question 4 then, pause it, have a go, come back when you're ready. Okay, so this one, these map scales, what this means is that on the map, 1 centimeter, for example, corresponds to 25,000 centimeters in reality. It's like a ratio, okay? Now on the map, the distance is 5.4 centimeters. So see, obviously I've multiplied 1 by 5.4 here, haven't I? All right, now if I want to know how far Swansea is away from Cardiff in real life, I need to find this bit here, which I do by timesing this by 5.4 as well. Okay, this looks scary, but don't be worried about it too much. Okay, so 25,000 times 5.4. Without the calculator, I'll do 25,000 times 54. Okay, and I will just do 25 times 54. Right, if you do 25 times 54, pardon me, with the box method, sorry, you get 1,350. But don't forget, there's 3 zeros to add on. 1, 2, 3. It's actually 1.35 million centimeters. All right, don't forget, because you times this by 10, you better divide this by 10 now here to put it back the way it was. Basically, take off a naught, so 135, and then it'd be 1, 2, 3 noughts on the end of it. In reality, okay, it's 135,000 centimeters. But it wants the answer in kilometers. So remember the connections now, okay? 1 meter is 100 centimeters. All right, and then also 1 kilometer is 1,000 meters. Now, if I've taken this here, this is in centimeters. To work backwards here, of course, you would divide by 100, wouldn't you? So you can just lose 2 zeros, 1350 meters, and then now to go from the meters to the kilometers, you divide by 1,000, and if you divide by 1,000, you get a really daft answer. This is obviously nowhere near the real life situation, but trust the maths, okay? According to this map, this is a dodgy map. Swansea is 1.35 kilometers from Cardiff, which is not true, but I checked the maths over, and for this question, the maths is correct. Okay, nice one. All right, number 5 then, pause it, come out when you're ready. All right, so these are on, it's on box and whisker diagrams. I call these box plots, all right, but the exam might use either version there, all right? So remember, a box plot looks like a box. Remember, where this is the minimum value, this is the maximum value. Here is the lower quartile, LQ. Here's the middle of the data, which is called the median, remember? And here's the upper quartile, okay? Now, the greatest time is 4 hours, 30 minutes. Okay, so that's 4.5 hours in there, all right? This is the max, okay? Now, the range of the times is 2.5 hours. So if the maximum is 4.5 hours, remember the range is the gap between the biggest and the smallest. All right, so if you do 4.5, take away 2.5, that's 2. The minimum is 2 hours. Okay? The median is 180 minutes. Well, that's 3 hours on this scale. All right. The lower quartile is 2.5 hours. Now, the interquartile range is 1 hour. Remember, the interquartile range is the gap between the two quartiles. So if the lower quartile is 2.5, the gap to the upper quartile is 1 hour. So the upper quartile would be 3.5 hours. All right. Put these on the box plot. Remember the minimum? If I'm going to do my scale, I'll go from 0 to 5. All right, 0, 1, 2, 3, 4, 5, and this is the hours. All right, and then I will have to, well, let me just do some straight lines here. Let's try and get this right, is it? So, shapes and a line. So I'll do my axis here. Okay, let's hopefully a straight line. And I'll just make it a bit thicker. Say 4 point. Here's my scale. I'll draw my box plot now, okay? So you need some vertical lines for each part now. So the minimum was, let me get a couple, 1, 2, 3. Oops, sorry. Be too clever. 345950. Okay, so the minimum is 2 hours. So that goes here. The lower quartile is 2.5 hours, which on my scale roughly is there. The median is 3 hours. The upper quartile was 3.5 hours. And the maximum is 4.5 hours, which is here. Remember now then, to complete the box, we will get some horizontal lines on you. Remember, and you will just join the quartiles, remember, like this, with a straight line. Hope I can get, yeah, there we go. Right? See, there's the central box here. All right, and then remember, you want to put the so-called whiskers going from the box to the max and the min. And there's my box plot right there. Done. Okay, finished. All right, so in the last part then, how many pupils played Warzone for more than 2.5 hours? Well, here's 2.5 hours. And can you see this is the lower quartile here? Remember, the lower quartile is 1/4 through the data set. All right, so hopefully there's 2 ways to do this, I suppose. All right, remember there's 80 pupils in the data set. If you work out 1/4 of 80, that's 20 pupils. All right, and then that means that there's 20 pupils here who played for less than 2.5 hours. You are more than 2.5 hours. So if you do 80, take away 20, that tells you what's left over, and that gives you the 60 pupils. Okay, that's that one done. And the last one here, pause it, have a go, and then come back when you're ready. Okay, so this one, so they got a 30% sale, and she bought foundation. It costed 28. How much would it have cost without the sale? All right, so if I do a little picture here, okay, before the sale and after the sale. After sale, it cost £28. Before the sale, I don't know. All I know is that this has gone down by 30%, okay, here to here. So I think without the calculator, we have to adapt our method slightly. Remember, if you think about it, our usual method, wouldn't it? If it's gone down by 30%, remember, then you would take 30% off 100. All right, and that equals 70%. Then you divide by 100, which gives you 0.7. Okay, so this shop's tills computer would have done normal price times 0.7 to get the sale price. But I am working the other way, aren't I? I'm working backwards. You see, I am working backwards. So to work backwards, you'd have to divide by 0.7. So I got to do 28 divided by 0.7. But divided by a decimal, make the bottom a whole number. By times it by 10. Top by 10 as well, then the numerator is 280. And 280 divided by 7 is £40. So before the sale, it was £40. If you want to check, you can, because 30% of 40 is 12. 40 take 12 is 28. Okay, and that's all done.